So today we'll start with the concept of connection oriented versus connectionless. So what do we mean by this connection oriented and connectionless? First of all, we know that connection oriented means we need a connection between two devices, a dedicated connection between two devices. Then we can tell it as a connection oriented system. Connectionless means will not have any dedicated communication path, but they can communicate with each other. Okay, so that's why connection oriented, we are telling the example of wired communication. That means two devices or more than two devices, they are connected by a wire. So that will be called as a connection oriented system. And connectionless means whenever we are talking about wireless communication. Okay, so our laptop is connected to the access point for the internet purpose. Then that kind of connection is called as wireless communication. Okay, so in that case, that type of communication is called as connectionless communication. So we can take some examples how we are using the connection oriented or connectionless. So the connection oriented, the examples like sequence of pages. Whenever we are just downloading one of the document or any of the file we are downloading from internet, then we are getting it as a sequence of pages. Continuously we are getting those things. So in that case, we need a reliable messaging stream. Okay, so that we are going to get the sequence of pages. Then whenever we need movie download. Okay, so whenever we are going for movie download, then at that time, again, we are using the reliable byte stream service. So that again, we need a connection oriented mechanism to get the movie to be downloaded. Then next type of example is voice over internet protocol. So sometimes you must have heard about this example, like in some of the organizations, they are using VoIP communication. Okay, so like you must have seen some of the intercoms in some of the offices where we are not using the analog communication of telephone communication or intercom. We are using voice over internet protocol over there. Okay, that means we are having the internet will be connected. So based on the internet only, we are connecting with themselves. Okay, so because the internet is involved there, so we are just telling that type of service is called as unreliable connection, because sometimes we may able to reach to the other end, sometimes we may not, because if internet connection will not be there, then we may not able to reach to the other part. But if we are using the analog communication, then there is a 90% chance or more than that chance that we can be able to contact with the receiver part. Okay, so that's why that kind of service sometimes we are calling it as a unreliable connection whenever we are using voice over internet protocol. But that is a connection oriented service. Okay, we are connecting that, but it is dependent on the internet as well as it is dependent on the power also. Okay, and for the connectionless, we are using electronic mail. So whenever we are talking about electronic mail, email, that is a connectionless service. We are not having a connection between the source and the destination. Okay, so that type of connection is called as unreliable datagram service. Then whenever we are doing the text messaging, whenever you are sending a text message from your phone to another phone, then and that type of communication is called as a connectionless service. And whenever we are talking about the database query, that means we are requesting something, we are getting the reply from the database. So that type of service is called as a request reply. So that is one of the example of connectionless service. So these are the different different types of services we are getting in case of connection oriented or connectionless services. Now we can see some service primitives. So the service primitives, we can have again 6 type of service primitives. First one we can tell it as a listen. We are listening to a connection. Okay, so the meaning of listen is we can block the waiting for an incoming connection. Now we are waiting that we may get one incoming connection, so that's why we are listening. Then we have to connect it so that we can establish a connection with a waiting peer who is waiting to get the connection. Now we are going to connect that. Then we have to accept that incoming connection from the peer. Okay, because now we have started the connection process, but we have to accept that one. So we are going to accept that. Then after that, receiving the incoming message, whatever the incoming message is there, once the path is established, once the communication is established in between the source and the destination, then we can receive the incoming messages. Even if we want to send any message to the peer to which we have established the connection, then also we can send a message. Then after the send and receive is over, now we can disconnect our communication, so that we have to terminate the connection. Okay. So these are the 6 primitives we are using whenever we are going for communication. Okay, so these primitives also it will be useful whenever we will use the concept of socket programming in our lab classes. Okay, so from the next lab class only we are going to start with the socket programming. Okay, so during the lab class only I am going to tell you that how we are going to start with the socket programming, but these are the primitives it will be useful in case of socket programming. Okay, listen, connect, accept, receive, send and disconnect. So in this way the service primitives is how it is working in between the client and server machine. Okay, so this is one of the example of client machine where the client process is there and client process is communicating with the protocol stack or kernel or drivers, which is called as a whole it is called as the operating system. Okay, so here also in the server machine the same concept is there, and they can first request connection request will be there, then accept the response, then a request for data, then it will get the reply as the data, then it is going for disconnects. In this way the normally service primitives are working whenever we are talking about client server interaction using the acknowledged datagram system. So whatever the data it is getting, it has to acknowledge that. So this is the way how the service primitives are working in case of client and server machine. Then the next one is the relationship of service to the protocols. So this one also we have discussed in the last class, that whenever we are present in one of the layer, that is if we are considering here it as a layer K, then in both the machine sender as well as in the receiver, the layer K, the protocols whatever is working in the layer K, it will be same. Okay, so whatever the protocols are working here in layer K in the sender machine and the receiver machine also, the same set of protocols are going to work for the layer K. And just below that layer we will have the layer K minus 1, and just up that layer, that is layer K plus 1 will be there. So in this way we are having the protocol stack will be there, and how we'll have a relationship, and layer K will have one communication path to the layer K plus 1, even if it will have the communication path between the layer K minus 1. Okay, so this is the way how the relationship is established. Then now we can see, now we'll have a reference models. Okay, so what do we mean by this reference models? That means something is already established, now we have to follow that as a reference. Okay, so we are having one model is there, that is called as a OSI model. So OSI model, it is a standard, we have to follow that. So that's why we are treating it as a OSI reference model. TCP/IP reference model. TCP/IP model is a standard, so we are following that. So that's why TCP/IP reference model. Then we can see the comparison between the OSI and the TCP/IP. Then whatever the critics are there for the OSI model and the TCP/IP model, that we are going to see. Okay, so now we'll start with the OSI reference model. Okay, so OSI reference model, I'll start with this slide. Okay, so now what we are going to see, The OSI is nothing but the full form. If you want to know, then it will be Open System Interconnection. Okay, so normally it is widely used and openly used the term OSI model. Okay, if you are going to ask to anybody, then everybody knows about that OSI model. Okay, OSI reference model or OSI model, whatever is suitable for you, you can tell. But what is the full form for that? The full form is Open System Interconnection. And you can see it was introduced by one of the organization. That organization is known as ISO. You must have heard about this ISO. Okay, so it is giving us a standard. Okay, so we are having the concept of standardization, network standardization in our syllabus. So after this topic will be over, we'll go to the network standardizations, those who are giving standards to the networks. So we are going to read about that. Okay, one organization, the most popular organization you may have heard about, that is IEEE. Okay, another one is ISO. Okay, you must have heard somewhere like ISO 9001 certified, ISO 9002 certified, ISO 10,000 certified. Okay, so these are different standards they are giving. So what is the meaning of that standards? Why we need the standard? Standardized means if any standardized body which is universally acceptable. That means if I'm talking about ISO standard, means that is a standard everybody knows. Okay, if you are following a IEEE standard, then that also is known by everyone. Okay, so that's why ISO is the organization which is called as International Organization for Standardization. Okay, so ISO, they have developed one of the mechanism so that everybody will follow that mechanism, that is introduced in late 1970s. Towards late 1970s, they have introduced that concept, that is open system interconnection. So in case of this OSI, what is there in that OSI? OSI is giving us different sets or hierarchy. Okay, we are telling it as we are having 7 layers are there in OSI model. And in each layer, what is there? Why we are going for that layering concept? Okay, so we are going for that layers because in each layer we are having a set of protocols. Okay, because whenever we are working with the computer networks, means then we are working with the protocols. Mostly we are working with the protocols. So without using as a whole, okay, I may be having 1000 protocols, 2000 protocols, whatever the number we have. Without using that whole set of protocols at a time, what we are doing, we have divided the task. If I am in layer 1, then I am going to use this set of protocols. If I am going to use in layer 2, then these are the protocols will be used. If I am in layer 3, then these are the protocols I am going to use. So in different layers, we are having a different set of protocols at present. Okay, so what we are doing actually, whatever the protocols are there in the OSI reference model, it will allow any two different systems to communicate regardless of their underlying architecture. Whatever the underlying architecture is there, it will not bother about that one. Okay, it will allow two different communication systems, two different computers to communicate. Whatever the underlying architecture is there, it will not bother about that. Okay, so in that only the OSI model is helping us. Then the OSI model, whenever we are answering for the OSI model, we should not tell that OSI model is a protocol. It is not a protocol. It is a protocol stack. Why we are telling it as a protocol stack? Sometimes you can read somewhere that OSI model is a OSI reference protocol stack. TCP/IP model is also called as TCP/IP protocol stack. So why it is called as a protocol stack? Because so many protocols are kept one by one. Because in layer 1 some of the protocols are there, then in layer 2 some of the protocols are there, in layer 3 some of the protocols are there. So it is working like a stack. So it is not a single protocol OSI. It is having a lot of protocols and it is kept as a protocol stack. So it is a model for understanding and designing the network architecture, which will be flexible, robust, and interoperable. Okay, so whatever the OSI reference model we are using, it is very much flexible. that it is allowing whatever the different number of protocols are there, we can use in different layers. Okay, and it is a robust technique. Okay, everybody can use that technique. And what about the interoperability is there in between different layers? That is also possible in case of OSI reference model. Okay, so I have already told you that it consists of 7 separate but related layers. They are having a relation between themselves, but they are separate layers. Okay, so each of the layer they are having a set of protocols, and whatever the information is needed to travel the message throughout the network, that information will be added or deleted throughout the process of transferring the data. So this is the way how the OSI reference model is helping us. Now we'll come to the actual 7 layers. What are the names are there for 7 layers? Layer 1 is physical layer, then data link layer, network layer, transport layer, session layer, presentation, application. And you have to remember these names for the whole life. You cannot forget these names. Okay, wherever you will go, you have to know about these concepts. So if at all you are working with a computer, then you have to know about this concept. If you are working for any organization, then also you have to know about this concept. Okay, so these 7 layers you can remember for all the time: physical data linking network, transport, session, presentation, and application. So these are the 7 layers are there. Layer 1 or the lowest layer is the physical layer, and the layer 7 it is the topmost layer. Okay, and from which portion the end user is working? Can anybody guess from which portion the end user is working? End user means we are the end user, those who are sitting in front of computer and we are working with. Okay, so can anybody guess which layer is very much close to the user?
So the application.
Application layer is very much close to the user. This is the correct answer. Okay, so what we are doing, the user is sitting here and it is sending the data, and the data will travel from the application to presentation, then it will go to session, then transport, then network, then data link, then physical, and from the physical layer it is connected to the communication medium. Okay, so whenever the data is going from the sender machine, then the data will travel in this way, like from application towards physical it will travel. And in the receiver machine, it will first reach at the physical layer. Then from the physical layer, again it will travel from data link to network, network to transport, session, presentation, and application. Then finally one end user is sitting here, which can see whatever the message we have received. Okay, so this is just the normal way, whatever we are telling in case of our postal system. Okay, if we are going to take the example of our Indian postal system, what we are doing there? First of all, we are bringing one letter writing pad or envelope, whatever we need. Okay, so previous days something like postcard was there, inland letter was there. Okay, so you must have heard about those terms. You must not have used those terms, but you must have heard about those terms. I hope so. So those were the things people were using for communication purpose, because at those time telephone was not there. Even if it was there from some time, but it was not that much of popular. So people were using that communication system for communicating any information from one end to another end inside our country also. So what we are doing at that time, whenever you are bringing one postcard, you are writing the to address, from address, then whatever the content you want to write. Okay, so after writing that, what we are doing, you are going to the post office, wherever the post box is there, you are just dropping that one into the post office, sorry, into that post box. Then after that, the post office people, they'll collect that one, then they will see that where is the destination address is written, that means the to address is written. Okay, so they will analyze that whatever the letter they have received, it has to travel to that destination address. So they will see how they can travel it, either by train or by flight or whatever the means they are using for the transport purpose. They will travel it towards the destination. So in the destination city, once it will reach at the destination city, then again it will be searched that where is the actual pin code. Okay, because first of all it will go to that state. What is the state is written, it will go to that state. So inside that state again it will travel to the whatever the district is written. Then from that district, wherever the actual post office is present for that pin code, it will go to that portion. Then after that, the post peon of that post office, it will deliver to that home, whatever the home address is written. But again, one thing you can remember what is happening there, that postcard, it is not means for the whole home or for whole house. Okay, it is for one person in that house. So once that letter will reach into that house, then it will be again delivered to the person for which that letter is meant for. This is the whole process of communication. Now if we come to our communication purpose, then again the same thing we are going to follow. To address and from address we are going to use. Whatever the message we want to send, that will be also with us. Then it will travel through the communication medium. It will reach at the destination machine. Then it will checked, it will be matched that whether the destination address, whatever is written in that packet, whether it is matching with that destination address. If it is matching, then it will be delivered to that machine. Again, in that machine, there are so many processes are there, and that message, it is intended for a particular process. It is not for the whole machine. Okay, so once it will be delivered to the machine, then it will be searched that to which process it will be delivered. Okay, so that to that process only it will be delivered. So that type of communication, initially whenever it is delivered from one computer to another computer, that communication is called as host to host communication. And whenever it is delivered to one process, and here also in host machine one process has sent, so that type of communication will be called as process to process communication. Okay, so we are using the host to host communication as well as the process to process communication, but host to host communication is a broader concept. That means from one computer to another computer. Process to process communication is a very deeper concept. Inside that host to host communication, again we are going for the process to process communication. Okay, so we'll see in detail about all these things, but now we have to know that what are the responsibilities of different layers. Okay, we have seen 7 layering concepts for the OSI reference model. Now we can see that whatever the different responsibilities are there for different layers. Okay, so from these 7 layers, the bottom 4 layers, they are considered as the lower layers, and top 3 layers, it is called as the upper layers. So upper layer, it is considered as the application layer. Okay, and the lower layer, it is meant for the data transport purpose. So in the lower layer, it consists of physical layer, data link layer, network layer, and transport layer. Up to transport layer, we are using for the data transport purpose. After that, we are using the application concept, where the presentation, session, and application is going to one. Now we'll come to the one by one each layers we are going to discuss. The first one is physical layer. So here in physical layer, what is the data unit? That means whenever the data is being transmitted for the whole OSI reference model, it is present in different names. Okay, as like you are having different names in your home, maybe your parents are calling with a different name. Whenever you come to your friend circle, then friend circle may call you with a different name. Whenever you are going to another office, okay, wherever you are working, then they are calling you with a different name. Okay, so like that only, the same person but different names we are following. So here also, whenever we are going for the data communication, during the whole communication medium, that means whole communication path, like from layer 1 to layer 7, we are having different names are there for the same data item. So in the physical layer, what is the name or the unit of that data? That is called as bits. Data is present in the form of bits in the physical layer. Okay, so you have to just remember these terms only. So in physical layer, it is bits. Then we can go for the data link layer. Then it will be frame. Then in the network layer, it will be packet or datagram. Then we can go for the transport layer. Okay, so where the data is present in the form of segment. Then session layer. Okay, top 3 layers, it is called as data. These are the things you have to remember. Top 3 layers, that is application, presentation, and session. Those in those 3 layers, data is called as data only. Then data, segment, packet, frame, bit. In these way only you can remember. These are the 5 terms you have to remember: data, segment, packet, frame, bit. Okay, so these are the terms you have to remember, so that it will be helpful whenever we are discussing about what are the data units in different layers. So now we can start with the physical layer. So in physical layer, the data is called in the form of bits, and it is responsible for physical connection between devices. What is the responsibility of the physical layer? It has to just establish the physical connection between devices. So that's why the physical layer is responsible. Then movements of individual bits from one node to another node, that is the responsibility of the physical layer. Then the devices whatever we are using in case of physical layer, repeaters and hub, these are the devices we are using for the physical layer. Then what are the functions are there for the physical layer? The functions includes, it converts bits into signals, because whenever the data is traveling from application towards physical, then in the physical layer data is in the form of bits. But from the physical layer, when it will go to the outside world by the help of the transport, means whatever the transmission medium is there, if it is going to travel by the transmission medium, then data is traversing, data is traveling by the form of signals. Okay, so whenever data is traveling in the transmission medium, it is going in the form of signals. So that's why whatever the bits are there in the physical layer, now the bits are going to be converted to signals by the help of the physical layer. And also we have to go for synchronization, because we are having a lot of bits are involved, because we know that in computer all the data whatever we have, that is in the form of bits. So we must need one of synchronization mechanism, so that after which bit the whatever the bit is going to come, so that synchronization we need. So bit synchronization is very important. Then manage the physical connection. Whatever the physical connection we have, that physical connection will be managed by the physical layer. Then the bit rate control, whatever the bit rate we are following. Okay, that means how many number of bits per second we are transmitting. You must have seen this one, that bits per second. Okay, so that bit rate control can be done by the physical layer. Then the line configuration, like point to point or multi-point concept, whatever we have seen, which type of line configuration we are using, that will be also controlled by the physical layer. Then the physical topology, whatever the different topologies we have seen. Okay, so bus, star, ring, mesh, hybrid, whatever the topology we are going to follow, that will be also controlled by the physical layer. Then the transmission mode, like simplex, half duplex, full duplex. So whatever the transmission mode we are using, that will be also controlled by the physical layer. Then if we are using any kind of multiplexing, till now we have not discussed about multiplexing. That example also I am telling you. If I am having more than one signals are coming, 1, 2, 3, 4 signals are coming, and they will be combined by a system, and we'll get a single signal or single wave. It will transfer by the transmission medium. So if multiple number of signals they are combined and we are getting a single signal, then that will be called as multiplexing. Okay, again, what is demultiplexing? Whenever from a single signal we are getting to the original form, that means here we have combined 4 signals, means then at the end, receiver end, we are getting the again 4 signals from the one signal, then that concept will be called as a demultiplex. So that is also the job of the physical layer. And switching. So in case of switching, that means from one place to another place, whenever the data is going to be transmitted, then at that time also we are using the physical layer is helpful for that one. Okay. So these are the responsibilities of the physical layer. Then I'll come to the next layer, that is data link layer. So what do we mean by this data link layer? Okay, so before going to the data link layer, we must have one interactive session about the physical layer. So what are the responsibilities of the physical layer? Can anybody answer like 2 or 3 responsibilities? If you can answer, then it will be sufficient. That means you are listening. Okay. So can anybody answer? What are the responsibilities of the physical layer? In which form data is present in the physical layer?
Bits.
Okay. Okay, so anybody else wants to answer? What are the responsibilities of the physical layer? Okay, you are not answering, but always you should listen carefully in the class, so that at any time I may ask personally one by one also I can ask. So please listen it. Okay, whatever the concepts we are discussing, these are one of the important concepts from the subject point of view. So please listen it carefully. So the next layer, whatever we are going to discuss, that is known as data link layer. And in the data link layer, the data unit for this layer, it is called as a frame. So that what is a frame? If we want to know what is a frame, then it is a group of bits. Okay. So if we are creating small groups for the bits, then that will be called as a frame. So data is present in the data link layer in the form of frames. Then now, if we want to know much more detail about this data link layer, then we have to divide this layer into 2 sub layers. Okay, there are so much tasks are there for this data link layer, so that's why we are just dividing it so that we can differentiate that what are the 2 types of jobs we are doing by 2 sub layers. So what are the 2 sub layers are there? One is MAC sub layer, another is LLC sub layer. MAC is media access control, and LLC is logical link control. So these are the 2 sub layers we are using. So now we will see what are the responsibilities of these 2 sub layers. MAC sub layer is, you can see that whatever the name we are using for this sub layer, media access control. That means how we are going to access the medium. That kind of concepts are present in the media access control or MAC sub layer. So this MAC sub layer, it controls how a computer in the network, it gains access to the link resources. That means to the transmission medium, how it is getting the access, and we are getting the permission to transmit. Whenever we are getting the permission that we are now able to transmit our data, then only we are going to get that. Now we are going to transmit our data. Okay, so we are having a very, one module is there for this media access control. We'll see that how we are giving permission to a device or a computer in the network, so that at which time it can transmit the data. So that is coming under media access control. Then the logical link control, mainly the data link layer is having another responsibility that is called as flow control and error control. Okay, so the logical link control or LLC, It controls the frame synchronization, in which way the frames are being transmitted. So that synchronization will be done by the LLC, as well as the error control and flow controls is also done by the LLC. Okay, so these are the different responsibilities of the different sub layers. As a whole, this is the responsibility of the data link layer. And whatever the tasks you can see here, we have combined now. DLL tasks are framing. So whatever the bits we have received, now we have to frame, we have to make a frames. Okay, make a list of frames. So that concept is called as framing. That means we are creating frames. So framing, physical addressing. So physical addressing, what is that? Okay, till now we know that we are writing the address. Whatever I was giving the example of one envelope, whenever we are writing the to address and from address. So now we are having the two addressing concept, that is known as physical addressing and logical addressing. So what is the meaning of this physical addressing and logical addressing? Physical address is nothing but one of the address which is present for our computer. It is a permanent address. And the logical address is which is given to the computer. It is as like a just we can see, we can tell that it is a temporary address. As like whenever you are just filling up any form, in that form you are applying for a job or you are applying for higher study, then they are asking that what is your current address, what is your permanent address. Okay, permanent address is not going to change, but the current address may be able to change. Okay, we may change our current address. So that type of addressing here we are using physical addressing and logical addressing. Physical addressing, it is nothing but, if you have heard about a name MAC address, that concept is coming from this MAC, media access control. Okay, so physical addressing is nothing but a MAC address, which is a 48-bit address. Okay, and whenever we are talking about the logical address, that is nothing but the IP address. In each computer we are having two addresses are there. Okay, so one is physical address and one is logical address. So physical address is the MAC address and the logical address is the IP address. Okay, so MAC address we are not changing, we cannot change it. It is a permanent address, it is given by the manufacturer. And the logical address, it is given by any of the service provider, because IP address, it is directly connected to the internet system. So whenever we are connecting to internet, then at that time we are using the IP address as the logical address. Okay, so the job of the data link layer, it is for physical addressing. Whenever we go to the network layer, the logical addressing will come in that place. Then the error control and flow control, these are the tasks of data link layer. And what is the device we are using in data link layer? That device is called as a bridge. Okay, so in physical layer we have used the device as hop and repeater. In case of data link layer, we are using the device as bridge. Okay, so we'll stop here for this data link layer today, and for the other layers we'll discuss in the next class. So do you have